Hello, this is the interim presentation for DfM for Arbor Press. Team members Darren, Krishna, Santosh, Aman, and I'm Will. This is for the fall semester 2022 ISD 528 class. The product that we chose to do DfM analysis on for this interim presentation is the Arbor Press. An Arbor Press is a small hand-operated press used for operations like staking, riveting, installing, and configuring and moving bearings. It's typically found in a machine shop. It is a manual process for essentially just pressing things together. They're typically rated on the amount of leverage they can provide, which is 1 to 5 tons typically. Primary customers for this product would be machine shops doing sort of lower volume manual assembly work, fabrication. Secondary customers would be non-industry level people like hobbyists using the press in maybe a garage or in a small business or in a workshop that they have in their home. For our fast diagram, primary function was to press part, and that's done by applying force, stabilizing part, applying leverage. Stabilizing part can be farther expanded to preventing translation. That's ensuring that the part that you have fixtured to the base doesn't rotate off, and you can get a clean level press of your two parts together. For leverage, that can be farther expanded into creating torque, and that's done, as you saw in the picture, by rotating the lever and using the gearbox, which we'll get into later, to press the two things together. For assured dependability, once again, levelness is very important to make sure you get the flatness on the two parts that you're mating together. And for convenience, allowing portability to where the product can be moved from workbench to workbench or thrown into a truck or something like that is important to the customer, as well as variety of different parts that they can use with the machine. And for senses, we included the providing handhold, a comfortable place to grip when you're using the product. For assembly sequence analysis, this is our exploded view for the product. You can see on the balloon diagram to the left that there are 17 parts. There are several parts that have more than one quantity, fasteners being the most obvious, as well as the two knobs that attach to the lever that gets turned. But the main parts outside of that are the base and the frame, and then the gear assembly, the ramrod, and the lever. So for top down, what our first sequence analysis, we start with the frame, and then we'll assemble the gear assembly. So on that exploded view on the left, you can see parts 10, 11, 12, 17, and that fastener being put together. Then we'll assemble the gear rack. After that, we'll assemble the shaft cap with the fasteners, and then that'll get pressed together by the front plate, part number 15. And then finally, we'll install the ram head and then assemble the base. So the bottom up is our second sequence analysis, and exactly like it says, it's the reverse order. So you're starting with your base, your press plate, your frame, and then you're putting the gear assembly and the handling lever towards the end. We decided upon analysis that the bottom up sequence is the better option to go with. You can see that it beats the top down assembly in a lot of the categories, most notably transferring and handling and locating parts, because you're starting with the base, and it's much easier to use one hand and locate some of the assembly areas as you assemble. For our mapping matrix, we found that the fasteners, the knob, the shaft cap, the front plate, and the washer are all not part of the function. So we might be looking to redesign or do DfM around those. All other parts apply some sort of function, as you can see. For BOM and costs, you can see all 17 parts listed. Our total cost for manufacturing the Arbor Press is $244.20. For our quad chart, as mentioned earlier, we are looking to eliminate a lot of the fasteners and some of the pens, and then looking to redesign the base, the frame, the press plate, and the gear rack, based on the fact that they are high manufacturing costs, but high importance. So we still need them. Product family design, for functional differentiation, we kept everything the same except for providing handhold and apply leverage, as for our two different customer bases, we can change that up. And what that comes down to for component commonality is a redesign of the knob, handle rod, and handle shaft components. So starting from the bottom up sequence, which we decided was our best sequence, our family product design changes right as you assemble the handle shaft, because as mentioned earlier, that's the part that we're going to change based on the two customer bases, as you can see here. So what that looks like in terms of product design, you can see here in the CAD model that we are going with a crank shaft rotating piece for turning the gear assembly versus the two-sided lever with the knobs for our hobbyist base, because of it making it require a lot less space for the area, and also ease of just using one hand. And this would have a trade-off of the amount of force that you could potentially apply, but they wouldn't need the same level as industry type fabrication. So those are our two different family designs there. Thanks so much.